It's time to take care of business, and that job I've been putting off for an awfully long time. You see before me a Ti99 project that I started quite a while back and have been regretting ever since. This is the complicated test harness I have constructed around this. Initially it had a fault with the video display, and you can see I've changed all of the chips here to socketed video RAM chips, and that's good. There's not a problem with the video display right now. The only problem is with the keyboard. And I've swapped all of these components that are the ones connected directly to the keyboard, but I really suspect it's the main CPU, which is the TMS9900, because it seems to me that the TMS9900 isn't sending the appropriate clock signals to this periphery chip, which is the TMS9901, which in turn isn't multiplexing the keyboard multiplexer, which in turn isn't seeing the keyboard. Now when I do hotwire this to raise an interrupt, the screen on the Ti99 does progress. So there is life, but not as we know it. So today's mission is to remove this guy, and I've been putting it off because one, it's hard to get hold of the chips, and two, look how many pins it's got. So I actually ordered 2 more of them because I do have another Ti99 and I'm not taking any chances. It's hard to get hold of these. And I have some SIP headers. So without further ado, I just have to start desoldering this chip. But before I do, let's pay some special attention to this blue wire. So TI do have these quite annoying buses. So I'm going to turn it over. You can see these bus bars. You've got these bus bars and these jumper wires. First thing I'm going to do is dip my little brush. I've got a little brush with some flux on it, and I'm going to paint over those pins because we want to make sure they're nicely fluxed up. And flux is a little bit like a metal lubricant, so we'll let that metal flow. There we go. We might find ourselves having to add flux to this, and I hope, oh yes, I do have a little bit of leaded solder left. I need to top up on that. Of course, with these boards when they were made did use a lead-based solder. So I'd advise if you're trying to desolder it and you need to add additional to get your solder sucker working better, to go with the same. You'll get a better result. In fact, use leaded solder when you can. So I'm just going to try this one, which I've primed with some solder. That was pretty good. And we're going to try the next one, which we haven't primed with some solder, to see if that works. Yeah, it's okay. Not quite as good. Let's try another one. Yeah, it's okay. I should have just left it a little bit longer. Let's do another comparison with these two that are side by side, which one we have primed up and one we haven't. So the primed one first. Looking nice. And then the one we haven't primed, also looking nice. Gives you quite the workout. Of course you can use some electrical automated solder suckers, but I've never really got on with them, and these jobs are so infrequent and occasional. This is fine. And also for delicate work, it is nice to be able to get in there and really see what you're up to. I'm noticing when we come to solder this, we need to be a bit careful because some of the components, they don't look quite as nicely covered with the solder resist as you'd like. So just make sure you don't bridge anything when you come to solder that SIP in. One more, and then I think we'll have a jump cut. How about that? Yeah. That's the first pass done. I'm going to flip it over. Let's put this heatsink on the side before I put my elbow on it. Ooh, now what I want to do is just gently prise the chip, just to see if there's. Oh, hello, hello. I think that worked. You can see it rocking. That's pretty awesome actually. I wasn't expecting that to be so compliant, but it has come away. Now if we can get the other side convinced. I'm pressing against this bus bar, so it's a bit naughty. Let's try this side instead. Oh, a few of them went. Oh, that was awesome though. If we could just achieve the same again, that would have been brilliant. I got a good wiggle on that with that chip. So 1, 2, 3, 4. It looks like these next 8 actually didn't clear nicely. So I'm going to just top those guys off again. And what I'm going to do is I'm going to put my soldering iron up a couple of degrees hotter. Let's cook these babas. Okay, so now that's pretty molten. Press that in. And that was as good a seal as I could get. It feels we really are just down to a couple of sticky pins, so I'm just going to grab it here. Just give it a wobble. See if I can identify, and I can identify the pins, the area where we can maybe get some targeted localized heat and convince them to let go. Let go. Come with us. Nice. There we have the TMS9900 out, but we don't want to mistreat this. This could still be a pretty good chip, and there's not that many spares going by, so I'm going to keep that aside. Because of course, after all of this project, it might still not work, and then we'll have to start again. But I have these. These are turned pin connectors, or turned pin sockets rather. If you look, they're round. They've got round little holes rather than the leaves. Now this does make them a little bit more awkward, I have to admit, in the insertion and removal, but they're very tenacious and they're very good quality. So once your chip is in this, it will not want to leave. So you're not going to get that heat cycling happening where you have to bash your computer on the desk or push all the chips down after a while. This will lock them in forever. Stay a while. Stay forever. And also use this as an opportunity to have a look at the holes that you've got there to make sure no tracks have been lifted. I can see from here there's nothing. It's absolutely stonkingly good, which makes a change. So we've cut those to length. You can keep those somewhere. One day you'll need those, I promise you. So put them back in the bag. And you're going to get your other sip in there. And with a bit of dexterity, keep your fingers pressed on both of those, and then flip it over so you can see this side. And again, check to make sure there's no defects. 0 defects is what you're looking for here, which we have. I'm going to bring a bit of solder there. You can see that bit of solder because I've got this all one-handed, so I'm going to put a little blob on the end of the iron. And then I'm just going to tack one of the pins on each sip, like so. And then I'm going to press on the back of the sip where those pins were, which is this end, and just push them home again with a bit of heat, and then just push them home. Make sure they're, ouch, all the way in. Of course, if you're pushing directly on that pin, you'll feel the heat transferred into your fingertip. That's the socket tacked in. I'm just going to gently bend it because it's not quite square. But what you could do really is probably just put the chip in now if you wanted to, but I think it'll be okay. It's pretty square. I'm just going to put it over now. The chip itself will adjust accordingly. You could always bend the pins on the chip slightly to accommodate the socket. And you can see I'm just gently filling them in from this side. I like to give a little blow, you know, a little puff as I'm doing them, you know, just to make sure that the smoke isn't going straight into my eyes. And you just keep doing that, making sure not to bridge anything, don't linger too long. It's fine. Ooh, nice. that's pretty much done. I did notice here between these two pins that bit of tracking was looking a little bit dicey. In fact, I had to bend it away from the pin. So I just want to make sure, I'm going to take out my meter here and just make sure there's still continuity on that, because we had to move it. Sometimes you might get a very tiny break and you just would not see it. And that's what could cause something like this not to work. So I'm just going to go from here, follow that to here. Yep. And then we can see where that trace is going right there. So good, that still works. And just as a sanity check, let's see if it's got continuity to any of the surrounding pins. It hasn't, so it's not shorted. Good, right. So what we can do now is flip the board over, and then we're going to get a fresh chip, and let's see how they compare. It'd be interesting to see how they compare there. Yeah, I mean the numbers are basically the same. There are a couple of numbers there, but they could just be the date codes. So let's just try it. That's all we can do. We knew at least last time it did boot up and you could see the screen. It was just the keyboard not working. And what you can do, preserve your sanity, take your existing one, mark it with like a smiley face or something in there. See it there? Pop it back in the tube before you destroy its pins accidentally. You will notice, of course, I didn't remove those wires. I kind of felt that I could get around them, and I think I can quite successfully there. So I'm just aligning some of those pins. Now take a lot of care on this part. Remember, these are turned pin connectors. They really need them to be nicely aligned. They won't play ball if you're slightly out. And if you need to, just wiggle it on the socket slightly so you can get them to engage. And then just push down once you start feeling them going. But if you see one getting bent, then just leave it be. Don't push down anymore. Reset it, straighten the pins. If you find it seems that one or two are being a little bit troublesome, just put a little bit of pressure on, and then with a probe or tweezers, whatever you've got, just push them in gently into the dished section of that turned pin. Take your time, and eventually it will just drop in. You'll find that. Naturally, after you've done that, you've put your chip in, you can hook up all your electrical connections, as I have, rather dubiously, just to check there's no shorts. And then you can plug it in and see your success. Ooh, there we go. TI screen, and you heard the beep. All we need to do is hit a key and see how good this was. No! Yep, that's everything replaced twice now.